Hi everybody, my name is Ivan Boyle and I'm with Mozilla's security assurance team, and part of my team works on security tools and automation. One of the areas that we've been working very hard on is making security tools that are actually usable by developers and tools that they want to use. So this is a talk about some of the work we've been doing for the last year. And although we've mentioned Minion in public and we've done a little bit of press about it, this is our first major release to a security community that we're actively encouraging people to use. So a little bit of an introduction. The Minion team is made up of several people. Minion was originally my concept, but because I'm actually a manager and I don't actually get to do stuff very much anymore, after I got past the initial concept and idea, the first thing I did was meet with my development team to get some people on board to help out. So the Minion team is comprised of really four key groups. There's Stefan Arentz, who is the lead architect and lead developer for the project. And then we've also had a couple of interns. Yukon is working with Mozilla right now. Today is actually his last day with Mozilla. And then we had an intern named Matthew Fuller, who was the person who took the proof of concept and ideas that I had for Minion and wrote the initial 0.1 version with the help of the other developers. And then along the way, we've had significant contributions from pretty much all of the members of the security assurance team at Mozilla, whether they're people who are working actively on doing security testing or ideas on how we should implement things. So at the core of it, the big question is, what is Minion? And ultimately, it is a security automation framework. The goal of Minion is to create wrappers for a variety of different security tools so that the developers who want to use these tools don't have to know the nitty-gritty about how to configure and invoke them, how to get the results out of them, how to interpret the results, and how to share that information with other people. So we wanted to create a mechanism that they could use the different tools, share them, get collaboration with other developers in their team, with collaboration with the security team at Mozilla. And we also wanted to make it so that we could offer different levels of configurable scanning with each of the tools that we're writing automation for. So everything is designed to run through a web interface. It's designed as a completely open source project. We've developed it in the open on GitHub. It's been available since the very first scripts were committed to it. But we've just recently hit a 0.3 milestone, which had a lot of the features that we needed to be able to share it with the community at large, and that teams outside of Mozilla could start using it. So I could talk a lot more about what Minion is, but instead of doing that, I'm just going to jump right in and start demoing it. So this is the Minion landing page. It looks terribly uninteresting. It just has a big login button that uses our federated identity protocol called Persona. And for those of you who aren't familiar with it, if you Google me or Google Persona, you'll find information about it, including a couple of talks I've given about Persona and federated identity, and there's a bunch of other information available online as well. So basically, you just use a Persona account to log into the application, which I actually have to do. And I'm not going to give away any details, including password length. So then it actually proceeds with the login and proceeds with the login. There we go. And you can see that this is actually our production instance. So you're seeing some of the high-level results of the different scans that have been performed, things that have been done. You can see the different sites that we're already actively scanning. You can see the different categories of results that we're seeing based on how those scans have been configured. You can also take because I'm an administrator, we can also jump in and take a look at the administration console. You have the ability to add users, different sites. You can see that we have features for verifying whether or not sites have been confirmed as being owned. And basically, this whole platform is focused around two major features. We have plugins, which are individual wrappers around tools or individual scripts that have been implemented as Minion plugins that are embedded into the application. So you can see that we have a plugin for Skipfish, which is a web fuzzer for people who aren't familiar with it. We have a plugin for Zap, which you'll hear a lot more cool stuff about Zap if you stick around for Simon's talk after mine. And then we have things for basic checks like looking whether or not you have content security policy configured and configured properly for your site. We also have a bunch of informational checks looking for whether or not your website is emitting X-frame options, stuff like that. This is basically just the catalog of plugins that we currently support. And then off of plugins, you can go into plans, and a plan is just a configurable set of plugins that are designed to work together. So you can look at the Zap plan, and whoops, you have to actually click on edit to be able to see what a plan looks like. And it's just a JSON object that describes how the plan should be invoked. And there's more to it that you can configure, but I'll talk a little bit more about that in a bit. The important thing is when you're working in Minion, if you go back to the default view, if you are just a regular user, normally you'd only see the sites that you have access to. I am an administrator on this, so I can see everything. But you can go down, and at any point in time, if a developer has been given access to the website and they want to go in and run a scan, all they have to do is click on scan, and it'll run the configured plan. So as you can see, just by clicking on it, the scan starts running in the background, kicks off, and in real time, as the scan is running, you'll start to see results showing up. And I'm not going to go into the detail. I'll go into the detail view so you can see the details about the scan. But because that's running on a production site, I'm not going to go into the individual details of the issues that are reported. So it has some high-level information about what's been reported. You can actually click on each of these to get more details. You can take a look from the scan to see which checks are being run. And because we're only at the 0.3 release, we haven't implemented the full reporting set, but we want to be able to produce reports that people can actually just go in, developers can get immediately the results that apply to things that they want to fix or things that they might be interested in. And we can customize the scans to make sure that we're only reporting things that are actually exploitable conditions, so developers don't have to worry about dealing with false positives. So that is plugin specific. If you have a poorly written plugin that generates a lot of false positives, there's nothing that Minion can do about it yet, but I'll talk a little bit more about some of the things that we're going to build into it in the future. So that in a nutshell is what Minion is. I'm going to talk a little bit more about the architecture, how it's built, and why we think it's an extremely flexible and customizable platform building out different things. At the end, I'll stop and ask if there's any questions, and there's more to come on how you can try Minion out for yourself. So some of the goals of Minion are, as I mentioned before, we want the ability to automate testing. So there's tons and tons of different tools that are vendor-specific, open-source, proprietary, that you can use to do automated scanning and get results. The problem is most developers will look at the results and say, I don't know what any of that means. I don't know how to turn that into actionable data. Different tools have different value in the types of information that are provided by the reports. The advantage to Minion is that because the Minion framework itself wraps all of the different tools that we support, we can actually capture all of that information that those tools would generate in their report and include it in the results for developers while constraining it to information that's actually useful. Minion also has the ability to capture and store all of the test results. The plugins themselves generate a report, but the plugins also store the entire detail and result set that the individual tools generate. So if you're working as a developer, you see a report, you don't understand something, you can say, hey, I ran this scan, here's the scan ID, and you talk to your security team member or whoever is giving you access to Minion and ask them to take a look at the results and give you a more deeper explanation. If the person who is investigating that wants to, they can download all of the artifacts from the original tool, including the configuration that was used to scan the application, and examine that and see what in particular caused that result to be reported. That's also useful if we find a vulnerability that's not reported by Minion. We can go back and take a look at what scan configurations are in place and what the results are and figure out what the gaps are, and then report that back to the tool authors to help drive improvements to the tools that we're using. Minion is designed for everyone. When I started talking to the team about building something like this, we had a couple of particular challenges that we were trying to deal with. Last year, some of the people in my team got together. We worked with our QA team to rewrite a tool called Garmer that basically allowed us to generate very simple, straightforward security tests that people could incorporate into with continuous integration tools. The problem is that even though it was really easy to use, nobody was using it because the reports, the quality of the results and the types of things were too incredibly simple. It was easier to just incorporate test cases directly into the application. So in the end, I think despite the fact that we ended up spending about a month and a half to 2 months of development time working on it, split across 3 different people, we only ended up getting, I think, 2 websites and one of the QA teams at Mozilla actually using it. So we set out with a different set of objectives, and instead of designing something that we thought would be useful to developers, we talked to some of the people in our organization, we got feedback from other developers, and I talked to the actual developers that work in my team about what they could use in a project they're working on, and that's kind of how we came up with the designing concept for Minion. So we set out, the intention right from the get-go was to create something that could be used for everyone. It's really easy to develop tools internally and consume them within your organization, but one of the things about Mozilla is we have these 10 guiding principles, and if you search Mozilla principles, you'll find them, and there's a whole pile of them. They're all really interesting, and they all talk about how we are heavily focused on the user. But the one that's really important to the people in my team is that individual security on the internet is fundamental, and it cannot be treated as optional. Now, that doesn't mean that users can't back out of security choices. If you go into Firefox, you can actually configure Firefox to disable a lot of the security features. We don't recommend that. But you can do it because you're the user, it's your choice. User choice is more important than principle number 4. But one of the challenges is that there's not a lot of security tools out there that are designed for anybody to start using. If my mom has a blog, she's not going to be running any tools against it to check if it's secure. She's going to be calling me, and it's the same problem in the rest of our organization. It's really easy for me to support my mom, but it's really hard for me to support the 900 developers that are, 900 staff members that are employed by Mozilla, and the thousands of community members that we support on an ongoing basis. So overall, there's a couple of different problems that we aimed to solve with Minion, and the first one is that testing fundamentally is hard. It's not because performing, repeatable security testing is something that's overtly challenging. Anybody can take a list of things that you need to test about an application and run through them. But the problem is, it's a lot of grunt work, and unless you have a defined checklist that you make sure you do all of these things for every application, you end up missing things as you iterate over a large list of applications. The other side of that problem is if you use that checklist and you become dependent on it, and that checklist is the only things that you check for an application, then you stop revisiting things and trying new techniques, and you become more focused on adhering to that checklist of things to fix. The other thing is that when you're working on doing security testing, most of the security test cases that you're going to come up with are specific to an application, especially in the web security space, where business logic is heavily baked into every single web application that you look at. So it's really easy to test if you go through manually, but writing an actual repeatable test case that somebody else can run is a lot harder than actually just going through and firing up an intercepting proxy and performing some testing yourself or running a fuzzer. So we wanted to create a tool that would allow people to leverage the work that they've already done in generating test cases. And I'm not going to go into too much detail about repeatable test cases because, as I said, Simon's got a really cool talk coming up right away. But when we set out to build this, the mission was originally to build a tool that works for us. The 0.1 release got us there. We were able to give access to our developers. We were able to talk to our QA team, get them interested in using Minion, and they're actually starting to use it for some of their internal applications. We have a program at Mozilla called Security Champions, where we have volunteers from all of the different project teams and business units that get involved and take ownership of security in their area, and they become the security leads for the projects that their teams work on. All of the security champions were given access to this and invited to give us feedback. We had to make it work for anyone. It's simple. You put in a URL in a website, you hit scan, you get results. And we accomplished that right off the hop. And the third one is because we're Mozilla, we wanted to give it away so everybody can use it. It's available on GitHub. There's links and all of that bit for at the end of the presentation for people who want to get access to it. The other thing is we wanted to make it a really low barrier of entry for contributions. So writing the front end, writing the task engine, building everything so that it could be super scalable was a bit challenging. But the way that we were able to accomplish that was by completely isolating everything so that all of the individual tools would be authored as plugins that could be invoked completely separately from the platform. So the ultimate objective is to automate everything. There's tons of different security tools that you can find online. We want to be able to write wrappers. We want to be able to make it easy for individual tool developers to write wrappers. So in order to explain a little bit more about how people can do that, I want to jump into the typical flow for how a person uses Minion. So basically, once you've got an account set up, you can go in, you configure a target, which in this current iteration of Minion is a URL. And then from there, you can go in and configure a plan. Now, hopefully that pops up over there. Nope. Yeah. I don't know if everybody can read that, but as I showed before, a plan is just a simple JSON object. It's a list, a brief description, a name, and then a workflow that describes each of the individual plugins and the order in which they'll be invoked, as well as any configuration parameters that can be set for that. It's extremely straightforward to write these. As we get into future iterations of Minion, we'll have a scan builder built into, or a plan builder rather, built directly into the web application. But right now, in order to iterate quickly, we just said JSON object, easy to edit. So that's all it takes to get a plan authored. And then once you have the plan, you can immediately start running the scan. You saw how easy it was. I just went and hit the button and immediately results started showing up. And you can access the results by navigating in, or you can actually I think that we broke the feature temporarily to download the individual artifacts because we're writing better access controls around that. From an architecture perspective, it's not a terribly complex application. The front end itself is written in Angular.js and it invokes a Minion API. That Minion API is provided by a back end that is built on top of Celery and Twisted. And the plugins themselves are just Python script wrap tools. We've got a couple of different templates for how they can be invoked. We have a template for writing a plugin that is just a simple Python script. We have templates for wrapping command line utilities, and we have templates for wrapping extremely complex tools like Zap. Those are all published. They can be built off very easily. And it's designed, again, the focus here is to design it for everybody. The holy grail would be to get somebody who's working on a platform like Kali or Backtrack, for people who don't know that Backtrack basically turned into Kali. We would love to get a tool like that involved and wrap all of their tools and get them all easy, like one-click invocation on a target through this front end, so that in developers being able to get results. That said, from a technical perspective, it's pretty lightweight to describe how it's built, but the top is kind of like an organizational flow of the application. So the user interacts with the front end interacts with an API. The reason that's important is one of the design requirements from the get-go was each of the individual components had to be isolated. So you can rip out the front end and replace it with something else if you want to. Even within the front end, one of the next releases will have a feature so that you can describe different landing pages and have different extensions for how users actually interact with Minion itself. On the API level, not on the API level, on the task engine level, it's basically just a backend designed to facilitate all of the incoming scan requests and perform scheduling and queue management, and make sure that we can route the requests to the right plugins, and interact with the different plugins, which don't necessarily have to reside on the same server. The plugins themselves can be exposed via a network API, or they can be installed alongside the task engine. The reason why we designed this is because we wanted to be able to scale up to support any number of websites, but in addition to that, there's some operational challenges with building these types of scanners. If you want to scan deep into an environment, it means you either have to open up a bunch of holes in your firewall, or you have to have scanner head ends in different environments. We wanted to support both options. So if you have a scanner that wraps something like, did I lose volume there? No, okay. Wraps something like Rapid7 or Nessus or something like that, you can have that tool wrapped and running in a plugin, and then the only attack surface that's exposed from having that tool is the very simple JSON network call to be able to invoke the plugin and get the results. Everything else is managed and run. There's no significant breach of your security perimeter in order to open up those tools. The next component is the individual plugins. So the plugins themselves are run in servers, and they're run in a way that the plugins themselves are considered disposable. If a plugin crashes, or a plugin takes too long to respond, the task engine can say, okay, you go away now, and it'll kill the plugin service and start a new plugin. The next step for that is to build it up so that we can have plugin servers that are running as, for example, Amazon EC2 AMIs. So you can dynamically allocate a new plugin from a pool of instances that you have, run it for the duration you need it, then kill it off and recycle the resources. You can do something else with them. These are all features that are on the roadmap that we're designing so that we can actually have this as a scalable service. But to get more into it, the important model for developers that want to support and contribute to Minion are how plugins actually work. So the plugins are, like I've said, they're a Python wrapper for individual tools, and each plugin has to support a very basic set of APIs. There's a lot of flexibility in how they can be implemented, how they report results, whether or not they're a blocking plugin that just executes a tool in the background and then only reports back results when the tool is completed, or if it streams back results so that you can have that real-time update in the front end as individual issues are found. The entire focus of the plugins, as I've mentioned, is that if something goes wrong, throw the plugin away and create a new instance. Don't worry about whether or not you want to manage the plugin, try to do any kind of recovery or anything like that. Security tools crash frequently, especially if they're not exactly the best written tools. In some proof of concept tools are not very reliable. So we want to make sure that we can support even those tools. So in order to look at how a plugin itself actually works, I'll just have to pop this window open again. So here is an example of an actual plugin. So most of this document, this is an alive plugin. All it does is basically does web ping to make sure that the service itself is alive before it kicks off a scan. This is really useful if we can't talk to a box, if we can't reach the box. There's no point in trying to run skipfish and zap against it. It's just going to be a pain in the butt. So the plugin itself says some information about it, the type of scan that it is. So plugins can actually support multiple weights. So this is so that in the front end, you'll be able to configure whether or not you want to do a light scan, a heavy scan. If you want to allow fuzzing tools, you'll be able to do much more generic scan configurations just by selecting from a drop-down. Then you have some links that you can provide for further information when you go into the detailed view for the individual plugins. And then, although you can be much more robust in how you report things, this particular plugin implements the reports with a couple of JSON objects that it just fills in the data and allocates, or like it just returns a result from the reports dictionary here. The plugin itself and every plugin is basically implemented within this do run piece. In this case, it's actually just running a couple of requests through curl. But most of the plugins that we have are written to execute tools. The big ones right now are Nmap, Skipfish, and Zap. There are contributors that are working on other things. There's a team that's working on building a plugin around Arachne. And then I'm personally working on a plugin for OpenVAS to show how you can use tools like Nessus or Rapid7 or any of those other infrastructure scanners from within Minion. So you can actually just invoke those and have them running in this at the developer's request, which is fairly useful when you're getting into DevOps scenarios where you have your developers being responsible for pushing infrastructure configurations as well. So it's really straightforward. It's really easy to write a simple individual check. And the key thing is when you're running and configuring and building Minion instances, as soon as you install the plugin itself into the Python path, Minion will discover it. So you just have to add it in, do a very small amount of configuration in terms of setting up the setup of the tool, and then it just becomes available to Minion, and Minion can start using them. So this is how Minion actually invokes plugins. So when you call a plugin via the task engine, it actually gets added to the task engine and put into a queue, and then the task engine itself cycles and pulls back items out of the queue, kicks off the scans, and invokes all of these on a priority basis. We're working on some improvements so that, for example, you can set a user to have a higher priority so they'll be able to consume more resources and things like that. But we figured it was better to get something out there and ship something that's usable and keep people up to date as we ship new features. So it's really straightforward. The other thing too is the plugins themselves are considered discrete applications. There's some command line tools that ship with Minion. So if you want to do continuous integration, you can either write a job in your, a task in your CI platform to be able to call out to Minion, a Minion server and run scans on your behalf, or you can simply write a wrapper around the command line tools to invoke a plugin using a command line API. So you can immediately start using plugins whether or not you want to have a full-blown Minion instance. Okay, so if anybody who wants to create plugins, Yuke, our intern who finishes today, wrote a really great blog post. The link is there. As soon as I'm finished my presentation, I'll be tweeting a link to the slides as well. So it'll show up in the hashtag AppSec EU stream as soon as I'm done. So you can actually have a read through that blog post. It goes in more detail, step by step, what you need to do, the different things that you need to be considering when you're writing a plugin, and shows that you can not only write plugins in Python. He has an example of a cookie checking plugin that's written in Go. So it's not bound to a specific platform. You can write them however you want and just invoke them from within a plugin. So the vision of Minion is to see a lot more integration with free tools. Okay. Sorry, I'm using an HTML5 presentation and things got desynced there. So we want to get more integration with free tools so we can support different projects. Right now, the OWASP, or the only major web scanner that we're supporting is OWASP Zap, and that's something that's supported jointly by Simon and Stefan in our team. But we want to build out frameworks so that other tool developers can simply have a really straightforward thing rather than having to write their own plugin. They just can set up a configuration file about how to invoke their tool. So different things like that. One of the next big steps we're working towards is a correlation engine. So a lot of these tools return similar types of results. We want to work with other projects that have done work like this in the past and correlate the results of all of these different tools so that you can have a confidence level when you see a report. If you see something reported, if the tool has a confidence level, that will show up, but if it doesn't, then you can have false positives. If we have that correlation piece in place, then we can use some of the less reliable tools and correlate the results. So for example, if you find a cross-site scripting vulnerability or a blind SQL injection vulnerability, if you see that reported across multiple tools to try and test in different ways, it'll increase your confidence that it's something that you actually need to tackle and be able to maybe make a priority for actioning. The other thing is we're working with our QA team to support continuous integration. So we use Jenkins a lot. There's a couple of other platforms that we use. So we're going to start shipping plugins and extensions that will allow Minion to work directly with those tools and get results into developers' hands, into QA folks' hands, so that they don't have to worry about how their security results are being generated. They can just get them as they do things like run through QA cycles and whatnot. And then our next major milestone, we're spinning it up as a separate project called Cohort, but we're evaluating open source static analysis tools, primarily around Python and PHP, because those are two of our pain points right now. But we're also looking at JavaScript, and we want to build a set of extensions for Minion so that instead of just having to scan a website, you can actually point it at a repository and give the developers results as they're checking stuff in. And then the other part we're building is third-party integration. So right now, all of our plugins are standalone tools, but that's because that's all of the effort we've put into it. The plugin model was also conceived as something that could support taking URL and invoking that via a third-party service. So if you happen to buy one of the security as a service providers platforms or buy access to them, then we want to work with those people to make sure that there's plugins so that Minion users can have Minion results, get everything from here, as well as have that shipped off to a service provider so that the service provider can feedback their results and have that all in one place. It becomes a single dashboard for the security team, for the development team, for operations teams, kind of getting all of this information into one place. So the big thing is there's a few different ways that you can use Minion. The first one is to download the code and set up your own instance. It's incredibly easy. If you're using something like VirtualBox from Oracle, or if you're using any of the cloud service providers that can support importing an OVA file, we have both the source code and instructions to set it up, as well as a virtual machine that you can download. It's about 1 gigabyte, and just takes a little bit of patience, but you can be up and running with a few minutes once it's downloaded. And then finally, we are inviting people to use our Minion instance. There's no cost. You have to apply for an invite. It's a really straightforward process. You just have to give us your name, your email address, the sites that you want to scan, and some feedback about how you're going to use Minion, and then we will work on getting people onboarded. This is a beta service, so we are looking primarily for users who are okay with having a few road bumps, potentially having to deal with a runaway scan on an application server if that happens. It does. It's a beta service. We're still dealing with some of those issues, but it is open for invitations, and we will respond to people as quickly as we can in getting them accessed and making sure that they can actually start using the Minion platform straight away. So that's really everything that I wanted to talk about Minion today. I wanted to leave a fair amount. I ended up leaving about 5 minutes longer for questions than I intended to, but I would like to open it up for questions about the platform or anything else that we're doing at Mozilla.
So for the questions, please raise your hand and
Thanks for your talk. When you, for the first time, had announced Minion project, there were already existing open source projects with very, very similar functionality. So my question is, did you see them, and why did you decide to make your own solution?
Okay, so we did do an evaluation of some open source projects, and ultimately the reason why we went the way that we did was because the various projects that existed have already built their own branding, have their own, in some cases have their own trademarks, in some cases have their own workflows or professional versions that are built on top of it. From one perspective, we wanted to make sure we were creating something that's unencumbered. So it's free. Everything that we're putting into it, all of the features and plugins that we're building are free and open source without any restrictions whatsoever. So that's the first part of it. The second part of it is, from the different platforms that we evaluated, it would require re-architecting some of the components to be able to do some of our longer-term future goals. And in particular, on the front-end side of things, in order to expose this to a large number of users and accomplish some of our longer-term objectives around building out privacy scanning capabilities and supporting general web users to be able to do scans on their own web properties, whether it's a blog or a Tumblr feed or anything like that, anything that they have authorization to scan, we want to support users in being able to do that. We just decided that we wanted to make sure that we had something that was built with scalability and customization in mind as we move forward. So there were a few different projects we evaluated, and none of them met with all the criteria that we had. Any other questions? Okay, so I've got some of my business cards up here. If you're interested in getting more information about Minion, have any questions about it, feel free to grab one, and thanks very much for your time.